This episode of Photonics Hot List is brought to you by Aerotech, precision motion control and automation. Take control, speed, precision, performance.
Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Airborne applications for environmental monitoring and 3D terrain mapping, for example, are now getting a boost from a new compact, energy-efficient, and much more accurate LiDAR system. Researchers at the University of Science and Technology of China have developed a single-photon LiDAR system that can 3D map objects and terrain with high accuracy, even in tough environments like dense vegetation. This setup features optical apertures that are smaller than those in conventional systems and requires much less energy and lower laser power. The system uses single photon detection, ultimately allowing the imaging resolution to exceed the light diffraction limit. It also uses single photon avalanche diode arrays, essentially highly sensitive detectors. In a series of tests, the new system's LiDAR imaging produced a 15-centimeter resolution from about a mile away. Adding subpixel scanning and 3D deconvolution to the setup improved that resolution down to 6 centimeters from the same distance. The team is working toward implementing the single-photon LiDAR system into drones and potentially satellites and other spaceborne platforms. It becomes increasingly crucial to monitor the condition of bridges, tunnels, and other concrete structures as they age. But the number of those existing around the world and the massive size of some of them makes it very difficult to get a complete picture of their current status structurally. Now, a new optic-involved approach is in a prime position to help. A team of researchers from Drexel University College of Engineering in Philadelphia has designed an AI-enabled machine vision system that uses a convolutional neural network to analyze images of a concrete structure captured by a machine vision camera for identifying cracks and other defects. The setup includes a laser scanner to measure the shape of cracks in a concrete structure and produce detailed 3D images. It also features a LiDAR component to collect point cloud information on the environment around the defect to ultimately create a 3D map for more efficient inspection. In their work, the researchers found the system can accurately detect and measure cracks with varying widths. They hope to someday incorporate virtual reality and AI algorithms to enhance multi-scale inspection systems. In a quest for clean energy sources, a team in Rochester, New York is employing extremely powerful technology to explore laser-driven inertial confinement fusion. Researchers from the University of Rochester's Laboratory for Laser Energetics are using their Omega and Omega EP laser systems to prompt inertial confinement fusion, or ICF, a process in which a small amount of fuel consisting of hydrogen isotopes, deuterium, and tritium is compressed and heated to extremely high temperatures. This generates fusion and a huge amount of energy that could potentially drive clean energy sources like those in carbon-free power plants. The team's work includes a direct drive approach, which involves a laser heating up a target surface directly. They can then measure the frequency of the laser light as it's scattered from the target. This direct drive method does have deficiencies, however, prompted by laser plasma interactions. But the researchers are now working to alleviate those shortfalls to ultimately deliver high fusion yields and someday cleaner energy power sources. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Until next time.